In the previous lecture, we talked about the difference between a deductive and an inductive argument. In this lecture, we will focus on inductive arguments and especially on one crucial feature of them. That in order to see whether an inductive argument is any good, you always need to use background theories. This means that we can't use induction to derive theories from neutral data. We are always already relying on some theoretical beliefs. And that means that scientific theories don't just depend on the observations, they also depend on some presuppositions or even prejudices. But let's start at the beginning. Remember that a deductive argument is a valid argument in which the truth of the premises absolutely guarantees the truth of the conclusion. It is simply impossible for the premises to be true and for the conclusion to be false. An inductive argument, on the other hand, is a valid argument in which the truth of the premises gives good reason to believe the truth of the conclusion, but doesn't guarantee it. Here's the example of an inductive argument we saw in the previous lecture. None of the medieval texts we have studied argues against the existence of God, so nobody in the Middle Ages argued against the existence of God. And here's a slightly different, maybe more representative kind of example. I put 25 frogs in the freezer for a week and all of them died. So, all frogs die when they are put in the freezer for a week. In that argument, we take a limited number of observations and draw a general conclusion from them. That is an example of induction, not deduction. After all, there might be freezer-resistant frogs, and it just happened to be the case that I didn't do my test on any of them. In general, no matter how many observations we have done, it is always possible that the next observation is going to be different. So drawing general conclusions from data is always going to require induction. There's always some risk involved. Now, in the last lecture, we learned that we can recognize deductive arguments just by looking at their logical form, without needing to know anything about the content. In this lecture, we'll see that that's not the case for inductive arguments. Instead, we always need background theories about the content in order to assess whether a supposed inductive argument is any good. So let's look at the example of the frogs again. I put 25 frogs in the freezer for a week and all of them died, so all frogs die when they are put in the freezer for a week. What is the logical form of that argument? It's something like this. I did A 25 times and every time B happened. So every time I will do A, B will happen. Is that a valid argument scheme? Well, let's try it out. For example, let's say that A is putting my hand on a hot stove and B is it hurts. So the argument becomes I put my hand on a hot stove 25 times and every time it hurt. So every time I am going to put my hand on a hot stove, it will hurt. And that sounds pretty good. In fact, it would seem that perhaps I didn't need 25 trials to find out that it's going to keep hurting. Most people might have stopped after 2 or 3 attempts. But now let's fill in something else for A and B. Let A be ask someone a question in Dutch, and let B be they answer in Dutch. So the argument becomes, I asked 25 people a question in Dutch, and every time they answered in Dutch, so whenever I will ask someone a question in Dutch, they will answer in Dutch. And that, of course, is a terrible argument. I did my experiment in the Netherlands, and in the Netherlands, almost everyone speaks Dutch. So that's why I got the results that I did. But it would be wrong to conclude that everyone speaks Dutch. If I go to Beijing and do the same experiment, I will get very different results. So why is the argument about hot stoves acceptable, but the argument about speaking Dutch not? Well, it has nothing to do with the logical form of the arguments, because their logical form is the same. Instead, what matters is the content. Our background knowledge about the human body makes us believe that if something hurts once, it will also hurt the next time. On the other hand, our background knowledge about human languages tells us that speakers of a single language are often concentrated in one or a few geographical areas. And that means that you can't generalize linguistic observations made in one area to the whole world. You'll have to make observations all over the world before we believe your inductive argument. In order to assess this kind of inductive argument then, there are several things we need to know about the content that the argument is about. Specifically, we need to know at least two things. First, we need to know how probable it is that the things we are interested in behave uniformly. It is quite probable that my nerves will react to the same stimulus in the same way every time. It is highly improbable that there is a language which everyone in the world speaks. This is why we need less evidence in the case of the stove than in the case of the Dutch speakers. So we can see that our background theories about human bodies and linguistic communities play an important role in deciding how much evidence we need in these two cases. Second, we need to know whether the data that we have are representative. That is, whether they represent the subject matter as a whole and not just a small and special part of it. Suppose that I want to know what the life expectancy was of people in 16th century France. And suppose that all my data are about rich aristocrats. Then we know that those data are probably not representative. Socioeconomic status can make a big difference to life expectancy. To have representative data, we would also need information about middle-class townspeople, servants, farmers, and so on. On the other hand, suppose that all my data were about people whose name started with an A, maybe because I only have a small part of an alphabetically ordered registry. That would not make the data non-representative, since we don't expect the first letter of someone's name to have any influence on how long they live. Obviously, we are using background theories about life expectancy to make these judgments. We already know that wealth is relevant and your name is not. The general point then is this: inductive arguments, in which we draw general conclusions from our observations, can only be judged based on certain background theories. We already need to know a lot about frogs, or the human body, or linguistic communities, or life expectancy, or whatever, before we can decide whether our data are good enough to draw a certain general conclusion about any of these subjects. And that is a very important point for understanding science. For it means that scientists cannot just take some data and then draw conclusions from those data in a completely neutral way that is acceptable to everyone. When we draw conclusions, we rely on background theories. And other people with different background theories might draw different conclusions. So just by looking at the logic of induction, we can conclude that a scientist will always be a bit biased, will always be looking at the world from a certain perspective. There is no such thing as a completely neutral scientist who doesn't have any background opinions about the world and who looks only at the data. For the data alone will never allow us to draw any general conclusions. And without general conclusions, we wouldn't really have science.